How is it going, ladies and gentlemen? This is the Wolf Around, and it's great to see you here. What if you could run an AI agent on a low-end laptop from 2018? I built one, and today I'm going to show you how it works. I decided to develop my own AI agent using my expertise in AI inference drivers and GPU hardware acceleration with C++. First, I started learning about the structure of LLMs, large language models, and how they work. It felt like being an LLM engineer, and I began thinking about how I could design an AI agent that uses the lowest amount of system resources while efficiently accomplishing the user's tasks. Instead of explaining every technical detail, let me show you the current status of the project. After all, an image is worth 1,000 words. First, let me start the VRAM monitoring script so you can track the VRAM usage during runtime. The VRAM usage before starting my AI agent is 140 megabytes. Now let me start my AI agent. The total VRAM usage increased to 670 megabytes. As you can see, my AI agent uses only 530 megabytes of VRAM, far lower than most AI models require. Let's start the conversation by saying hi. Now let's ask a question that requires wisdom and explanation, like what do you know about cats? It gave us a pretty informative answer about cats. Now I want you to pay attention to the system specifications of this old laptop from 2018. It has a 7-year-old, low-frequency Intel i5 processor and a low-end GPU like NVIDIA 940MX with 2 GB of VRAM. My expertise revolves around developing high-efficiency software even for low-end devices. As you can see, I'm running a large language model even on this device using the AI agent that I developed. Notice that it's not an easy task to run an AI agent while also recording the screen. Now let's ask a complicated question about programming. Explain recursion in Python. As the AI generates the answer, a warning message in square brackets appears. Before explaining what that means, let me push its limits with a new question, like what is a koi fish, while its context is already exceeded. Context size refers to the amount of text, or tokens, that the AI can consider at once while generating a response. I developed an algorithm that allows the AI to generate responses even when the context size is exceeded, without losing meaning or truncating the response. Read the response, and you'll see that everything remains meaningful, even when there is no room for additional words. By the way, I'm currently maintaining the development as cross-platform for Windows and Linux. I'm still in the early stages of development, and I'm not sure if I can continue the cross-platform support. But with your help, it's possible. Hit the subscribe and the like buttons, and help me bring this to more people. Also, let me know in the comments if you'd like to test my AI agent yourself. Now I'll run my AI agent on Debian 12. First, I'll start the VRAM monitoring. Then I'll start my AI agent and ask the same questions that I ask on Windows. This time, When I ask you to explain recursion in Python, it only explains it theoretically. Let's ask for a code example. The context size is exceeded during code generation, but it still continues writing the code correctly. Join me on my journey to develop an AI agent with high performance and efficiency while keeping the system requirements low. In my next video, I'll show you how I further improved my AI agent. So make sure you have subscribed and liked the video. I'll see you in the next one.